Hi, welcome to this Open Security Summit session in January 2021, which is going to focus on using DSLs, which is domain-specific languages for testing. So thanks, to Andy for joining in. Right, this is a good example of a Twitter thread that triggered the conversation that would trigger the session. And for me, what is going to focus on is a topic that I feel that we don't spend enough time talking about it, which is actually using DSLs for testing, and also how to use it for security testing. So I'm a big fan of testing. I think that if you're not writing tests for the stuff you do, you're just making random changes on the application. And it's very important that you spend sometimes as much engineering effort in your testing suite as you do sometimes in the main code base. Because the better you're testing, the faster you go, the more resilience you have, the more you understand what's going on, and the better it is. The problem is in most test frameworks is they don't evolve their thinking. And what I'm interested about this is this idea that the way you evolve your thinking, the way you evolve how your test framework exists is with domain-specific languages. So Andy is going to kickstart this with his ideas, and then please feel free to chip in with some questions. And then I kind of want to move the conversation a little bit where some of the security use cases, because security, I'm a CISO and a CTO, so I have both hats, but I find that the security questions are sometimes really good at making sure that it's a very objective sort of end-to-end flow versus I just want to know this, this, and this. So Andy, over to you.
Thank you so much, Dennis. And hello, everybody. Thank you for coming to listen to our talk today. I'm very, very excited to talk about using DSLs for testing. This is something that has been a bit of a personal journey for me over the past decade. And it's something I'm very, very passionate about. So a brief introduction about myself. My name is Andrew Knight. You may know me as Pandy or as the Automation Panda. Currently, I am the lead software engineer and test at Precision Lender, which is a Q2 company. I'm located in Raleigh, North Carolina in the United States. So I believe over in the UK, it's afternoon now, but for me, it's 10 a.m. So if you want to learn more about me, you can follow me on Twitter at Automation Panda. You can also check out my blog at automationpanda.com. Before I begin my talk, I want to give a bit of a disclaimer here. I know this is the Open Security Summit, but personally, I'm not what you would consider your traditional security type person. I'm very, very much more into testing and automation. I do a lot with functional testing. I do a little bit with performance testing, a lot with test automation, a lot with behavior-driven development. But I haven't really done a whole lot of hands-on stuff with security. So if you want to lob like deep security questions at me, probably not going to get the best answer, but I do have that expertise in testing. And so what I would like to do today is hopefully bring some of my expertise with testing into the security space. The big question that we hope to answer today with this talk, or maybe not even answer, but just lift up, is this. How can we use domain-specific languages for security testing? This is not meant to be a talk that's a technical demo. I'm not going to be giving deep examples or telling you the way things should be done. But instead, I want this to be a big think talk where we raise this question and we have a call to action to think, are DSLs good and useful for security testing? And if so, how? And what do we need to do to make that happen? And so to help answer that question, I want to share my own story, specifically with programming, with languages, and how I came to use domain-specific languages for testing and automation. For me, it all started in high school, back around 2002. I was 14 years old. I had just entered 9th grade. And one of the requirements was that we had to obtain a graphing calculator, the classic TI-83+. I was in a special program for math science and computer science. And so in 9th grade, I had an intro to computer science class. And in September, in the very first month, one of the first projects we worked on were to write math formulas for the calculator using the TI basic programming language. Now, I don't know if anybody else had the similar experience, but that screen was very, very tiny. You know, you didn't have a mouse, you had to use buttons up and down, and you were literally typing in using the second key repeatedly. But I found programming to be absolutely magical. I could do whatever I wanted on that calculator. And so at first it was simple, like hello world prints, then helpful math formulas that I could actually use in my algebra and geometry classes, to then quickly thereafter starting to make very, very simple games just on this TI-83 Plus. And that's when I first really got into programming, and it clicked and I felt unstoppable. Then in the following years in high school, being part of that special tech kind of program, every year I was taking a computer science course. And so in 10th grade, I took a programming course in Java. And then that continued into the AP computer science course in 11th grade with Java. Also did a little bit of C++ on my own. And then in senior year, we ended up doing some Python as well as COBOL, of all things. That'll come back later. So I had this well-rounded experience of learning different languages at a very young age. And I was just fascinated with this concept of a programming language. The fact that you could tell a computer what to do. And there were many, many ways to do it, whether that was your calculator or, back then in the mid-thousands, it was primarily like a desktop kind of setup. I didn't even have a laptop at that time. Though my understanding of languages was still rather rudimentary, right? I knew that I could use this language to write code, and the code would be simpler than English, but it would be very, very picky about the syntax. If you put a semicolon in the wrong place, things are going to blow up. But nevertheless, it was all very, very logical, right? You instruct the computer what to do, and it does it automatically. Now, I didn't really understand at that time really what languages were. I just knew it was you put some words in a very specific type of syntax, and the computer knows what to do with it. I sort of presumed that the computer itself would provide the language of instruction for me. And so the Java and the Python was just somehow magically coming from the computer, and the computer in and of itself as a machine would just suck in my commands and know what to do with it. My understanding of languages grew and matured when I went to college. I knew from that very first month in 9th grade, I wanted to pursue computer science and software development and programming for my career. It had just clicked so well, and I loved it. So I went to Rochester Institute of Technology in New York. I did a computer science major. And in my college program, I continued to learn about languages and to continue to be fascinated by them. But in college, not only was I learning, how to use programming languages, but I learned how to make programming languages. I took courses like computer science theory, programming language concepts, functional programming, and ultimately compiler construction, where I made my own language as well as an interpreter and a compiler for it. That was a lot of work. And so my understanding of computer science as a discipline as well as languages very much matured. Some of the key takeaways I got were that if you want to be very, very basic, computer science is just the study of machine instruction. We're telling a machine what to do. That's what computer science is. And a language, being part of that, is just a tool for writing those instructions. That's why we can have multiple languages, because languages are essentially tools. An interpreter for a language is just a program itself that executes instructions in that given language. So like Python has an interpreter. In my compiler construction course, I made an interpreter for my little scripting language. And then a compiler is just another type of program for translating instructions. All a compiler does is it turns high-level instructions down into low-level, binary or assembly language executions or instructions, that the computer can better understand. And knowing all of this, if you put it together, you can essentially make your own language if you make an interpreter or a compiler. That's all there was to it. You're making a program to run programs. And that just blew my mind. I thought that was the coolest thing ever. So I don't want to get too deep into language theory or compiler theory, but just to give a high level overview of what it means to have a programming language and what it means to interpret that or compile that. Programming language it's just a set of instructions, right? Excuse me, the code you write in a programming language is just a set of instructions. They can be statements or expressions. So here I've got an expression, A plus B equals C. This would be a fairly common Boolean expression in any major language like Python or Java or C# or whatever. When we read this as humans, we know, okay, I'm doing some sort of comparison. I'm adding two variables together and I'm comparing their value to a third variable. But how does the interpreter or the compiler know what this means, right? They don't have a human brain. How does that break it down? That's where language theory comes in. Essentially, what a language does is it will take any statement in the language, any instruction, and break it down into a syntax tree, where it's just basically using a grammar of understanding, just like we would do in English, like noun and verb, and it breaks apart the pieces. So my expression truly is A plus B equals C. There's actually three parts here. There's an expression on the left, A plus B. There's an operator, that equal sign, and then there's an expression on the right, C. Boom, boom, boom. So we can break this apart in three parts in the tree. And furthermore, that left expression also breaks into three parts. That has an expression, an operator, and an expression. As part of language analysis, not only do we break apart the syntax tree, but we do semantic analysis as well to evaluate ultimately what those parts are in those leaves of our tree. So I can identify here, A, B, and C are identifiers, probably referring to some sort of variable. And then the operators, those plus signs and those equal signs, those control different operations. So if I see the operation for a plus, then that's probably meaning some sort of mathematical addition or perhaps string concatenation, depending on what variables those identifiers refer to. For the equal sign there, that's a Boolean comparison. Does this equal this? And it should return a Boolean result. So that's roughly how languages work, in that they break apart these pieces, they evaluate them, and then an interpreter would, if you wanted to use an interpreter to run this expression, it would basically dance the tree, visit the parts, and process as it goes. Or a compiler would take these parts and translate them into lower level instructions. So with this wonderful understanding of now how languages work and the fact that you can make your own languages, I did an internship with IBM while I was in college. That's what brought me to North Carolina. And the product I worked on was called Rational Business Developer. This was 2007-ish. At that time, Rational Software was a division of IBM Software Group, and they were focused on making tools for development. They had released Eclipse as like an open source project. And so a lot of Rational's tools were just built on top of Eclipse, including Rational Business Developer. Now, what this particular tool did, the main product for Rational Business Developer was a language called EGL. It stood for Enterprise Generation Language. And so the workbench, Rational Business Developer, had the compiler and the interpreter for EGL. And it also provided all that nice, rich IDE-like stuff for EGL, such as source highlighting, inline commands, refactoring, navigation, all the stuff you'd expect for a language like Java or C++ or whatever. And so the purpose of EGL was to be a very, very high-level business-oriented language that would enable people to quickly develop business applications. Things like managing database records, or making like a desktop app, or making a service, or even making rich UI web pages. That's what they called it back then. But EGL would not run on its own. What would happen is the Rational Business Developer tool would take your EGL code and then compile that into either COBOL, Java, or JavaScript. So it was essentially a translation, right? You could write your programs in EGL and then deploy them to multiple platforms, whether that was a mainframe platform with COBOL, whether that was a distributed platform with Java, or whether that was a web platform with JavaScript. Interesting story, when I first joined, they put me on the QA team in 2007, and that's where I first started doing test automation. I was doing test automation in EGL, bleeding edge, you know, before test automation was cool. But then in my later summers, I joined the developer team on the Rational Business developer team. And I actually helped write some of the EGL to JavaScript compiler. And, you know, because I had learned all that stuff in college and now I'm working on a team that's doing this, it was just amazing. I was having so much fun playing around with languages. You know, and this is also, you know, more old school JavaScript, you know, before we had nice things like TypeScript. So there was some pretty janky stuff going on in there, but that's okay. It's still fun. So I guess one of my big takeaways from my internship at IBM working on EGL was not only that languages were cool, I already got that, but I understood more of the purpose of a language. And that is that a language is meant to make instructions easy to write. The reason why we don't write everything in assembly anymore is because it's too arcane, it's too low level. We'd be repeating ourselves, there'd be all sorts of issues of, like, you know, safety. If you make a mistake, you could really screw things up. And so when we have these higher level languages and even higher level languages, you know, going from, say, Java, COBOL to something like EGL, EGL just was supposed to make it simpler. The language automatically did things for you. You could either be an okay EGL programmer, or you would need to be like a really, really hotshot Java programmer or COBOL programmer to do the same thing with a lot more lines of code. So the purpose of a language was to make the instructions easier to write. And so I took that to heart. So let's fast forward a little bit. Graduated college, 2010, yay. Then I did another stint at IBM after graduation, but then in fall of 2011, I joined a company called Netapp. They make data storage devices, big operating systems names on tap. So when I joined Netapp, I joined what was then the platform QA team in Raleigh, North Carolina. And my primary job on this team was going to be test automation. The team hired me because they actually had some contacts of mine from IBM who would join this team. And a lot of them, they were more traditional QA folks, you know, been in the industry 10, 20 years, focused more on like test plan and manual testing. They saw me as this new college graduate, hotshot programmer, right? Ooh, we can make him do all of the test automation for us. And I was okay with that because I love coding. They had known I had done test automation before at my IBM internship with EGL. So it's like I was already familiar with testing and automation. So it was a natural fit. I came over. And so this was like my second big foray into test automation. Interesting thing to note, at that time, Netapp did all of their test automation in Perl. That detail is going to come back in just a moment. So I joined. I'm excited. Netapp, great place to work at the time. Everyone's super happy. My first project was this. We had a team in Raleigh, we had a team in Sunnyvale, California, and we had a team in Bangalore, India. And so my manager's first job for me was to get the Perl test scripts that the Bangalore team was running every night, running in our Raleigh lab. Because Netapp was doing data storage hardware, the filers and all, like we were very much attached to hardware. We couldn't just spin up VMs and stuff. So like, you know, the India team ran our tests on, or our Perl test scripts in their Bangalore lab. We wanted to get them running in the Raleigh lab because we were setting up all this new hardware and stuff. We had to get it moved over. There were about 20 tests in this nightly test suite. They were called the BAT-BOT, Basic Acceptance Test / Build Overnight Test. Acronyms abound. And so I thought to myself, okay, this should be easy, right? The tests are already working. My managers told me this. The India team is running them on a nightly basis. They're giving results to us every morning. Even though I'm new to Netapp and new to Perl, it should be fairly straightforward to get this thing set up. However, the code didn't work. The code straight up didn't work. And so here I am. I'm new college grad, new hire, new to the industry. I'm facing imposter syndrome. What am I doing here? Did I make a mistake? Should I even be at Netapp? Should I even be in software? I'm trying to learn Perl. I'm trying to learn Netapp's automation. I'm trying to learn Netapp's hardware. I'm trying to learn how our platform features actually work. I was told that these test scripts are running every night. I was told that they work, and I trusted that. But when I bring them over to the Raleigh lab and I run them, they fail. And I try to change the inputs. I try to reconfigure things. I try to step through the code, make some edits along the way. Nothing I'm doing is getting these things working. They're always bombing out and failing, spectacularly too. And so I had this incredible self-doubt. And ultimately, I spent about a month, literally step by step, walking through each test case and proving it to myself that the code itself is wrong, that it's not me, it's the code. And so then after I had that, I had to have an uncomfortable one-on-one with my manager to explain the bigger issue that our test automation that we thought is working is straight up broken. On top of the fact that we are getting messages from our counterpart team telling us that it's working when in fact it isn't. So there were those two issues. Very, very uncomfortable. And so when we looked at the specific problems in this test automation code, even though it was what I would consider today to be a small set of tests, about 20 or so, and each of these scripts was not like huge. These test cases were fairly simple. They were doing things like rebooting the machine, taking it down to BIOS, running a few low-level commands, verifying responses. So these were fairly simple test cases. We're not talking about like hours long end-to-end, bashing it over the head. It was kind of like get in, do something. It should take only about 2 to 3 minutes tops per test, be done. But I learned that even though it's a very, very simple test and a very, very simple feature, something that as a human I could intuitively do, the automation for that test needed a lot of code. I mean, we're talking, maybe like 100, 200, 300 lines of code per test case. And I thought that was, it seems like a lot just for a few steps, right? Another problem I found was that code duplication was rampant. We had to do lots of repetitive operations with testing, like how many times do you have to log in? How many times do you have to reboot the filer? And so like these things happen, right? But the way this automation was written, people were not reusing code. They were not putting them in Perl modules or in functions or in classes. They were literally just copy and pasting operations rampantly. And that added to the burden of lots of code. Furthermore, there were no coding standards or conformity in style whatsoever. Perl is a very free-form language. There's more than one way to do things, is a mantra of that community. And so now every single test looks radically different from every other test, even though they're doing similar things. The tests were also out of date. People had not maintained them. And so when features changed, tests break, and then nobody was really making updates. And when it was time to make updates, they were very difficult to make because of the aforementioned problems. And just to put a cherry on top, there was no management of the source code. There was no version control. Well, there was, but nobody was using it. Well, what we learned is that folks on the Bangalore team would check out the copies of the Perl scripts and then make local edits, but never sync them back. And that's why the copies I had were just completely broken. And then, yes, on top of that, there were also those awkward organizational politics, but not here to talk much about those. So what did I do? I fell down the test automation rabbit hole. I painstakingly rewrote those 20 or so overnight tests for our existing hardware, and I actually got them running nightly. So I had to do a lot of Perl rewriting, a lot of hardware changes. And so I got that done. Yay, we got it running. Gold star for Andy, manager pats me on the back. Good going, boy. Great. So what do I do next? Well, it was time to move on to the next set of automated tests for the team. And guess what? They were also broken. Pretty much all of our hundreds of tests were broken. And so I then spent months to years writing and refactoring all the tests for the team. I mean, and when I say nothing worked, I mean, literally there was no single test that worked out of the box. And at this time, this was about, 2011, 2012, there wasn't a whole lot of education on test automation publicly. We didn't have Test Automation University. The testing community was there, but automation was still kind of like this new thing. It was being done, but it was bleeding edge. It was kind of, it was more of like a special thing than a normal thing in a lot of places. And so I had to learn how to do good test automation the hard way. And usually that meant seeing what was bad, trying things, refactoring, finding out that it was better, but not great, and continuing the refactoring process. And also keep in mind, within NetApp space, everything was proprietary at this time. So because we were doing NetApp's Perl, we were using some of their libraries. I couldn't just go out to Google and search either. It was all internal. Ultimately, I spent about 4 years at NetApp perpetually improving my team's test automation. And so as part of this, what I realized was my goal in test automation was trying to get my test cases into automation as quickly and easily as possible. We had a repository of hundreds of tests that could be run manually. We used a tool called HP Application Lifecycle Management, the descendant of Quality Center. And so in there, you had test cases with design steps, 1, 2, 3, 4, 5, do this, verify this. And we would link our automated scripts to those test cases in ALM. And so much of my job was either reading a test script and trying to fix it, or throwing it out, going back to the test case in the repository and just writing it afresh based on the steps that were there. And so if I'm writing these tests based on test cases, then I'm trying to basically turn English into code as quickly and easily as possible. And the more direct links, the one-to-ones I can have in my steps, the better that's going to be. Unfortunately, Perl did not make this easy. I don't know if y'all have ever used Perl, but it is not a good language for test automation, and it does not scale well for big projects. Perl is very, very free form. There's more than one way to do things. For example, if you want to make a class for an object, there's about 5 different standard ways you can make classes and objects in Perl. And I guarantee in the test automation code that I was working on, somewhere, someone had done each of those 5 things. No standardization. It's also kind of hard to read. Here's an example of just some random Perl code I copied from the internet. You can see it's a lot of symbols, a lot of brackets and arrows, not terribly intuitive to read. Certainly doesn't link to plain language very well. And it was almost like I was trying to develop a castle of automation on a hill of butter. That's what it felt like I was using with Perl. The language itself was an obstacle. For years, having known that languages were meant to help you do things, I found that in this case, Perl was preventing me from doing things. Unfortunately, I couldn't get away from Perl because all of NetApp's test automation, to the tune of millions, and I mean millions of lines across their entire company at this time, was written in Perl. All of their shared libraries were written in Perl. And so I couldn't just abandon Perl and start over. But I thought to myself, what if I could make a better language for testing? What if I could make a better language? Rather than cut and burn and try to move to Python or Java or something, because that is not going to fly. Could I make a better language and possibly have Perl underneath of it as an interpreter? And this is where I went into domain-specific languages. When we talk about programming language, there are essentially 2 types. A general purpose language can write software for any need. So when people typically talk about programming languages, they're talking about things like Python, Java, JavaScript, even Perl in there, right? That's a general purpose language because you can implement solutions to any problems using those kinds of languages. However, a domain-specific language focuses on one particular kind of problem, a domain, so to speak. And you've probably used some domain-specific languages, even if you didn't know that's what they were. Some of the most common examples would be SQL is a domain-specific language for relational database queries, right? You can't do just raw programming in SQL. Like you can't, build a web app in SQL. But SQL is very, very good at getting tables and rows from a relational database. HTML is a domain-specific language for web page markup. And another one, YAML, is a DSL for text format for object specification, right? So all these, they're not like what we would consider full-fledged programming languages, but these languages are essentially tools that help us with these kinds of problems. So what I did at Netapp is I created a domain-specific language named DS for automating our platform QA tests. DS was an acronym short for design steps. We would write our DS programs in text files that were extension .ds. And the DS language would be, or these DS programs would be executed by an interpreter that I wrote in Perl using Perl's parse recdescent library. DS had basic commands for test controls, and you could even have extension modules that you would call by name written in Perl that would use Netapp's libraries. So not only, so DS itself would handle a lot of the language type things like logging, reporting, assertions, whatnot. And then if you needed to do some specific Netapp things, you could just call another Perl module that you would write that in Perl instead of DS. And that would call Netapp's, tens of millions of lines of whatever you needed to do, reboot, login, all that kind of stuff. And so here's an example of one of my DS programs. Procedure, reboot, SP, and verify. There's a setup thing where I would run a module named store current SP version. Then the main part of it, I would run a module that would reboot the SP from the SP CLI. Then it would sleep for 180 seconds. Then I would have my verify, my assertions, verify that is the SP online, that would be a module call. Then I could have some things like verify two things are equal, two different module calls that return values, make sure those are equal. DS handled all of that test automation concern. The setup, the running, the sleeping, performing assertions, yielding results, giving a report, right? And then all these Perl modules would handle the Netapp specific interactions. And DS offered us a ton of advantages. The tests were much, much simpler. Like what you just saw was about 7 lines or so versus about 300 lines of Perl. Awesome. The parts were very reusable. You could reuse statements like verify or run. You could reuse Perl modules like checking SP versions. And a beautiful thing is that the automation was more stable, because if I can make one thing stable and robust and safe and then reuse it elsewhere, I can trust it's going to be stable everywhere. One of the most frustrating things with all the Perl automation was that it would just like randomly time out, disconnect, or it would just hang up on something. Right? And it was frustrating because it could happen anywhere. And you couldn't universally solve it because people had copy pasted code everywhere. But with DS, you're reusing a lot of these parts. And the language itself has built-in, retry and refresh logic. So it was a wonderful thing. It streamlined our automation development. It made it go so much faster. We used ultimately way less code. And we didn't have to repeatedly code redundant operations like logging and reporting and stuff. We even had parallel execution. This thing's beautiful. Ultimately, we ended up writing over 500 of our tests in DS. And that includes new tests for new features that we were pushing out, as well as rewriting old broken tests. I even had managers in different organizations asking my manager, how could Andy automate hundreds of tests so quickly when my team is struggling to automate like 50? So it was a pretty cool validation, like, wow, this is awesome. Unfortunately, the party didn't last forever. What I proved with DS that I carried with me to this day is that I proved that test automation domain-specific languages work wonderfully, that it really does solve a lot of issues, that it really can expedite your automation development. It can really reduce the amount of duplicate code. It can maximize reuse of code. It can handle a lot of those common repetitive concerns. I proved with DS that DSLs work for testing. Unfortunately, I also discovered that DSLs take a lot of time, effort, and expertise to build. I mean, I was spending months just building the language, the interpreter, and the compiler, and then doing perpetual maintenance on it. I left Netapp voluntarily in 2015. Netapp was having some tough times, and there was, like I said, there was some organizational politics. Unfortunately, I wish I could say that my managers above me absolutely loved DS and the progress we made relative to what had been done before, but it wasn't well received. Everyone on my immediate team loved it, and on the Bangalore team loved it. But my senior managers and directors, they didn't like it because it was different. It was the idea of making your own custom DSL for testing was different. It didn't align with the millions of other lines of Perl code that Netapp was doing. And so they were not happy with it. Towards the end, they kind of given me a cease and desist on that project. And I was like, are you kidding me? Do you not see how many tests that we're now running like around the clock that are yielding good results that are stable? Anyway, but once I left Netapp, DS, I'm pretty sure has basically died. There was no one there to maintain it. I heard for a while that the team was maintaining the test cases, but not necessarily the compiler or the interpreter, and is what it is. In retrospect, I wish that I could have had DS open sourced, so it could be public, but at that time, Netapp was entirely proprietary. They were not supportive of open source. And so it's like, even if I had thought of it and asked for it, it probably would have been dead on arrival. But despite that depressing end, good things are right around the corner. At my next company, something big happened to me.
Sorry, can I just ask a question? Right?
Oh, sure.
If you go back to the slides, that one, right? Mm-hmm. And I have very similar experiences, right? In variations of this, right? Is the problem, right, fundamentally, and I think you touched a little bit, right? The lack of understanding and funding for the maintainability of the test framework. Because you, in a way, you use your political capital, right? In a way, you use the fact that you do control some of your time, right? To make the business decision to instead spending 100% of your time writing tests or whatever that amount is, you said, I'm going to spend 70% of my time writing and maintaining a framework, and then 30% of my time writing tests, right? And then I'm going to use the word naive, but I'm as guilty as you are on this one. And the naive assumption was that the number of tests would be enough to prove the model, right? Somebody would just, like you said, somebody would look at the quality of the tests, look at the metric of the tests, look at what we're doing. That proves that the 70-30 split is very valuable. But I think, but then isn't the problem the fact that unless that 70-30 split of 70% of somebody maintaining and developing the test framework and optimizing it, and then the other 30% writing tests, unless that is acknowledged as part of the engineering effort, ultimately that will fail, especially once the key people leave. Yes.
In a nutshell, at a high level, yes. The way I looked at it was, like you said, I know what I'm doing. I'm going to deliver far, far more value by using some of my time to invest in the framework or the DSL. And I'm going to have way, way more output than I could ever have otherwise. But it's going to be, like I said, it's going to be a little different in what the outcome is. It's not going to be your traditional test case. It's going to be a little bit different. And yeah, that's why my immediate team loved it. But higher up in the political situation, the executives, the directors and all, they were kind of like, we can't have this because this is different. How are we going to maintain this in the future? It's like,
But it's a valid question, right? But I
Mhm.
think it's because I don't think the metrics are correct,
Mhm.
right? If you measure by number of bugs in the system, or you measure by even ideally the number of tests that you run, is very hard sometimes to know the difference between a scalable system and a non-scalable
Mhm.
system, right?
Mhm.
Because the reality is sometimes even that management layer, they don't pay the costs of bad tests or bad test infrastructure. They're not the ones actually fixing the bugs, dealing with the complexity, right?
Mhm. Mhm.
They just see the side effects of it, and sometimes it's easy to what's it called, to underestimate the value of it, right? Now,
Mhm.
in your case, who was running the tests? All the developers or just the testers?
So at Netapp, we were waterfall and we had separate teams for development and testing. So I was on testing or a QA team. We were the ones responsible for not only writing, but also executing the tests
But
and then
were the
reporting results.
developers also running your tests?
They were not running these tests, no.
Yeah. So I actually think that's the other piece of the puzzle that a lot of times missing. So,
Mhm.
and the way I measure this is that you should look at who sends you pull requests for your test
Mhm.
framework. So if the pull request comes from a developer, then you know they're using it. If the pull requests if both the framework and the tests are all the responsibility of the test team, then you know that, first of all, you always have a breaking system, right? Because every time there's a code change, by definition, that will break your test.
Yep.
And my argument would always be that you always want that, because if you make a change and a test didn't fail, you made a random change. But if the developer cannot fix the test at that moment in time, then they always have broken tests at their end, and they don't run it. And almost you don't go that extra mile of making your platform very easy to use and very easy to consume by the developers themselves. Because I actually think that in an ideal world, what the test team is doing is actually improving the test framework and writing corner cases, not maintaining the test suites, right?
Yes.
Cool. Sorry, I just found it. But I thought, like, I've seen this so many times. And
Yes.
it's one of the reasons why earlier on, I start to open source everything I do. Because I was like, look, if I'm creating something that eventually you guys don't understand it, I don't want to start from scratch.
Yeah. Yeah,
Game.
definitely. Yeah, I mean,
Yeah, cool.
there were a lot of lessons learned for me in my NetApp experience. I want to say, like, overall, I loved my 4 years at NetApp. It's just there were some of these issues that came up, and ultimately they led to me voluntarily leaving. I was also less experienced. You know, I made some mistakes myself during this time. So, live and learn.
I know, live and learn, man. All right, go to good news.
Cool. So on that note, I don't want to come off sounding too depressing about my time in NetApp, but I left in July of 2015, and I was kind of sad, because I had worked so hard on this thing. I was doing something I loved. I saw the value. Everyone saw the value. I mean, we pushed out so much more coverage. We were running so much more frequently. It was so much better, but it's unappreciated. So I was like, now what? Well, good things were around the corner. The next company I went to was named MaxPoint, and I was hired to be a QA engineer, again, focused on automation. They hired me because they saw what I did at NetApp and said, wow, that's cool. And my coworker at this company introduced me to something called behavior-driven development. Now, I'd never heard of this before. This is new to me. Remember, NetApp was pretty much all proprietary stuff at that time, so anything outside those walls didn't exist. Whereas BDD was kind of like a movement happening outside those walls. And so I started learning about this thing. And I'm not going to get too much into BDD or what it is and all, but essentially it's a set of pragmatic practices that help you make better software behaviors in your development practices. So there are two main benefits of BDD, collaboration and automation. On collaboration, what BDD does is it helps bring people of different roles together, gets them talking, doing helpful planning activities like example mapping. So that way everyone's on the same page. You don't waste as much time misunderstanding and miscommunicating things, writing your behavior specs out so that everybody understands them. But the latter thing is automation, because when you write these behavior specs in a formal way, you can then turn them into automated tests. And for the automation, it uses a domain-specific language called Gherkin. And so this changed everything for me. I drilled deep into Gherkin because what I saw in Gherkin is exactly what I was trying to achieve with DS. Gherkin is this domain-specific language for writing behavior specifications, or arguably writing test cases. Here's an example Gherkin scenario, very, very high level. Title, basic DuckDuckGo search. Gherkin has 3 kinds of steps for every scenario: given, when, then. If you're familiar with arrange, act, assert as a testing pattern, that's all this is. Given some initial state, when an action is taken, then verify the results. Given, when, then, arrange, act, assert. So an example test case could be, if you're trying to perform a DuckDuckGo search, given the DuckDuckGo homepage is displayed, when the user searches for Panda, then results are shown for Panda. This is just a very high level domain specific language where you have some keywords here that denote step types, and then you free form the step names, which this to me looks just like those DS modules. It was incredible. And so what happens is you write your tests in a high level, in the high level Gherkin, basically in plain language, just with a little bit of extra syntax. And then when you go to automate these, you will turn each one of these plain language steps into some sort of method or function in whatever programming language you're using for automation. So here's an example with Python. When the user searches for Panda, I have a Python function that matches based on step text, takes that text in as an input, and then does some Selenium WebDriver calls, find that element, and then send some keys to it and hit enter. This is basically how Gherkin test automation works. Gherkin is your high-level domain-specific language where you can write things as if they are regular test steps, as if anyone, whether they're a developer, tester, product owner, or manager, can understand exactly what the behavior is. You can write your test case in given, when, then, get agreement on that as part of the collaboration. And then later, once that's agreed upon, then you spend your time automating your test. And so this just blew my mind. This is exactly like what I was trying to do with DS. I had no idea that there were open source BDD frameworks out there for testing that did exactly what I had engineered. So what makes Gherkin so popular for testing then? This is my thesis on why Gherkin has become so popular and why BDD test frameworks have become so popular. BDD provided Gherkin as the first widely available domain-specific language for test automation. I'm not the only one who's landed upon this discovery that DSLs are great for testing, right? BDD frameworks like Cucumber or SpecFlow or Behave or JBehave, whatever you want to call them, right? All of them use Gherkin as their domain-specific language, and then they have these step definitions written in whatever programming language, right? These were the first major widely available DSLs. Anyone can pick up, right? And the thing about these that makes it different from DS is that the average user does not need to know how to maintain that BDD framework. The average person doesn't need to be a Cucumber contributor. They don't need to be able to go in and make changes to the Cucumber framework. They just need to use it. They just need to write their Gherkin and then put in their step definitions and then just run it, right? Cucumber is provided to them, or SpecFlow is provided to them. The BDD framework is provided to them. The DSL itself is provided to them. It removes that barrier of entry that DSLs can be difficult to build and maintain. And so when you unleash this upon the world, people are going to recognize this and say, wow, this is great. I find it interesting and kind of surprising that if you listen to a lot of the BDD thought leaders in the space, they would condemn this idea as heresy. They would say, no, BDD is more about collaboration. You shouldn't be using BDD frameworks purely for automation. That's wrong practice. And I think to myself, guys, you're missing the value of these BDD frameworks. You may have intended it more for the collaboration aspect, but even just by itself, a BDD test framework provides this off-the-shelf DSL that people find value in. And so I have even worked on projects where I've done BDD style test automation with Gherkin without doing any of the collaboration aspect because I find value in the frameworks. Now you might be thinking to yourself, well, wait a minute. This Gherkin thing, not so sure. Those steps seem really concise, a little too generic. Can I really write thorough testing with Gherkin? And I'm going to say yes. I've built more than one test automation project with BDD frameworks. In fact, at my previous company, LexisNexis, and my current company, Precision Lender, I've built large-scale test automation projects with well over 1,000 unique Gherkin scenarios using C#, SpecFlow, and Selenium WebDriver. SpecFlow being the BDD framework. Currently at Precision Lender, we have over 1,400 unique Gherkin scenarios. Each one is about 5 lines long. Each one is an end-to-end web UI test that logs into our application and does a path. That current project runs about 15,000 test iterations per week. It's continuous testing. So can you scale with Gherkin and BDD and domain-specific languages? Yes, you can.
Yeah.
So in the few minutes I have left, what I want to do is I want to pivot now. You know, I've shared my story about why DSLs are great, but I want to come back to our original question. How can we use domain-specific languages for security testing? What we got to remember is that security testing is just a special type of functional testing. You do something, you make sure it works. You know, so we could use something like Gherkin or a similar type of DSL to automate security type tests. So here's an example of one. Password security. You know, if you were to provide invalid login credentials to a login page, you know, one security test could be to make sure that the page doesn't tell you which one was wrong. It just says credentials were invalid. You don't want it saying the username was invalid or the password was invalid, arguably, because that could give your hacker a little bit more information. So here's a Gherkin scenario for that. Login page should not reveal which credential is invalid. Given the login page is displayed, when the user enters a valid username, but the user enters an invalid password, and the user clicks the login button, then the login page says credentials were invalid without specifying which one. Basic kind of security test. I know it's not fancy, but like I said, I'm not a security guy. So, but like here, you know, here's an example of using Gherkin for a type of security test. We could have another one, such as user logout or lockout. Scenario, lock the user out after 5 successive failed login attempts. Given the login page is displayed, when the user attempts to log in 5 times with invalid passwords, then the login page says the user's account is locked out and the user cannot successfully log in with the correct password. Right? Again, boom, right there. A third one, real quick. Limited user access. You know, let's say you have different levels of privileges for different users in your system. You would not want a non-admin user accessing admin parts of your application. So, you know, here's 2 scenarios. You know, given you have a non-admin user logged in, first scenario, then the administration menu is not displayed. They can't even see it. But more deeply, let's say the user were to try to do something devious and directly navigate to the administration URL. Now, if they were to try that, then what should happen? Then the application displays an HTTP 500 error page, and the error page does not indicate that that administration page was targeted, right? Kind of keeping it obfuscated. So you could probably write a ton of other security tests with a DSL like Gherkin or some other thing. So I've hoped I've planted some seeds so that right now you can just start thinking like, oh man, could I try this? Could I try that? Y'all as security experts will be much better at coming up with those scenarios than me. But nevertheless, you know, this is possible. Like even somebody like me with a domain-specific language could start to become more of a security guy, right? You know, I had never really thought much about security testing before. Like I've done a little bit like the things I've shown, but just in prepping this talk, it's kind of opened my mind a little bit too. So,
cool.
So let me wrap up real quick. I know we're like coming up on the end of time, but I do want to make just some big calls to action. I think the question I asked earlier, can we use DSLs for security testing? The answer is yes, we can. So now let's refine that question a bit. First of all, can DSLs make security testing easier and more widely practiced? If we have good DSLs for security testing, would that encourage like regular tester people like me to consider security vulnerabilities more and to be able to automate tests for that more readily? Second thing, is Gherkin a good enough DSL, or do we need a different one? Do we need something a little bit more specific to security? Or is Gherkin good enough and we can just roll with it? There are other tools out there. Like for example, there's something from a company called Trion Solutions called cycle automation, which is kind of like Gherkin, except that they actually give you the steps already implemented. So there are other tools other than pure Gherkin out there that could help. And finally, third, would it be possible for the community to write a set of standard security tests using whatever DSL they decide upon? That could be shared by multiple companies or organizations, whether directly just using those tests or using those tests as a template for their own tests. So that's what I got.
Andy, brilliant. And I'm going to have to this is so frustrating because we have so much we should be continue talking. And there's actually a bunch of stuff that's already happening kind of on the industry around this that we should continue. So let's meet up in a month from now, right? Sure. And let's basically let's continue these threads. And then we pick it up there. And I'm going to have to be rude and stop this because we each have another Open Security Summit starting, and we're using the Zoom session. But this is brilliant.
No worries. I look forward to continuing the conversation. Thank you so much.